Walking, talking mock for Pure 2, June 2022 by Mindful Maths. Please do like and subscribe for more. Hope this helps and good luck. Okay, question 1, binomial expansion. Lovely, easy, 4 marks. And it's asking you ascending powers of x. So make sure x goes up from 0 to first 4 terms. So we're going to have x cubed. Okay, so you're given the formula. However, we all know it starts 10c0 times 2 to the power of 10 times 3 over 8x to the power of 0. Then we're going to have 10c1 times 2 to the 9 times 3 over 8 x to the power of 1. 10c2 times 2 to the 8 times 3 over 8x all squared, and then 10c3 times 2 to the 7 times 3 over 8x cubed. No. Okay, so you literally put this into your calculator. We're going to get 1,024. 1,920x, and then here we're going to get 1,620x squared. Now make sure you square the 3 over 8 as well, and then 810 x cubed. Now some people, I don't know why I've been writing commas, that's incorrect. Make sure that you write with pluses, or obviously if it's negative, write negatives. And write the last statement. That's a lovely, easy 4 marks. Okay, question 2, trapezium rule. So, first question. You have a look. I'm not going to read it all, but something that comes out to me, you should read it twice though, is that x is in radians. So what's the first thing I'm going to do? Yeah, that is fine. Okay, always double check what is going on. So x is in radians, and the table below shows some values of x and y. Complete the table. Okay, so I'm literally going to put into my calculator y equals 1 minus log to the base 10 is already the standard log in some calculators. Sine of bracket. Now inside this bracket I'm going to put 2 numbers. I'm going to put 1 in, and then I'm going to put 2 in. Okay, to see what I get. Now I know that sine of 1, so I'm going to do 1 minus log to the base 10 of sine of 1. Close brackets. So 1.0749. Everyone else has got 3 decimal places, so I'd stick with 3, and I'd make sure you round appropriately. Okay, and then I'm going to do the same, but I'm going to substitute in 2, 1.041. That's a nice easy 2 marks just for substitution. Okay, and it wants 3 decimal places, which we did. Use the trapezium rule. Now, remember, you are going to get method marks for this. So first of all, the height is the gap between the x values. So we know that our height is 1 minus 0.5, which is 0.5. And then they've given us the formula. Now, the formula is 0.5 over 2. Now, you have to write this out. If you don't write this out, you do not get the marks. It's really important you write out this whole thing. Plus, the first one and the last one, make sure you spend time writing this out. Remember, this is 3 marks to show that you can write it out. Plus, 2 lots of the middle. Now, they give you this in the formula book anyway. Okay, you're going to write this whole thing, and you're going to do 2 things. You're going to put it into your calculator as it is. Ooh. And when you do that, you're going to get 2.96. okay, to 2 decimal places. The next thing you're going to do is in your calculator, I think everyone's got the integration button. So in your calculator, if you actually put in the integration between 3 and 0.5, okay, because those are x values, of 1 minus log to the base 10, brackets, sine, bracket, x, bracket, bracket. Make sure you do all those brackets or else the calculator will get angry at you. And it won't help you. So log to the base 10, brackets, sine of x. Where's my x? Oh my god, I've lost it. Alpha x, and then another bracket. Press equals. Okay, I don't know what's my calculator's just gone blank. Okay. Now when I've pressed equals, I know why. So I got minus 0.3, which was wrong. I forgot to put the 1 minus. Okay, and when I press equals here, it is loading, I get 2.89, okay? Which is roughly the same as 2.96. So you know that you're on the right path. Remember, this is an estimate, okay? So this is an estimate. So that's a nice, easy 3 marks. Then it says, part C, use your answer of part B to find an estimate for this one. Okay, so this is where people get caught out. So, first of all, what do we notice? How can I make this to this? Well, first of all, by the way, this is just a transformation. Okay, we've added 2. So the graph is moved up by 2. So we know that is going to, the area is going to be bigger if the graph is moved out. And if we have a look at this, we can actually, 3 is the same as writing 2 plus 1. Okay, so the integration of 3 plus log to the base 10 of sine x is the same as writing the integration of 2 plus 1 plus log to the base 10 of sine of x. Okay?
I did 4 minus bracket 1 minus log 10 sin x.
4 bracket minus 1.
4 minus bracket 1 minus log 10 sin x.
Yeah. Well, what we notice, so this is why, is because actually, what did we have? Minus, what have I got? Plus. Okay? So that's not really going to work, but this is how the manipulation works, okay? So actually, it's better, I think, right, how could I get this to be a minus? Well, if I want 1 and minus log to the base 10 of sine x, what number could I put? Actually, I could put minus 4. Why? Because 3 is also 4 minus 1, isn't it? Yeah? So this is what I can rearrange this to. So this is all about manipulation. Now, again, this is between 3 and 0.5. So we already know what the integration of this is. So we can separate this now. We can have the integration of 3 between 0.5 of 4 with respect to x minus the integration of between 3 and 0.5 of 1 minus log to the base 10 sine of x with respect to x. We already know what this is. What did we work it out to be? 296. I now need to work this out. Okay, so what's the integration of 4? 4x. 3, 0.5. So could you just put this into the calculator? It's 3 marks. I think they want to see you integrate that 4. Okay, so you can put it into the calculator anyway, just to give you the answer. But if you're not showing that you can integrate that, you're not going to get the full marks. So you're going to get 4 lots of 3 minus 4 lots of 0.5 minus 2.96. Okay? So then we get 10 minus 2.96, which is 7.04. And that's how you get those 3 marks. So make sure you're showing all of your work in. Okay, question 3 part I. Show that the following statement is false. So n plus 1 cubed minus n cubed is prime for all n. Okay, so for part I, what do they want to see? You trying a few numbers, right? Let's put 1 in. When n equals 1, what do we get? 1 plus 1, 2 cubed minus 2 cubed. What do I get? No, sorry, it's not 2 cubed minus 2 cubed minus 1 cubed, which is 7, so that doesn't work. N equals 2. What do we get? 3 cubed minus 2 cubed, which is 19. Okay, and we can try a few ones. Normally, I try like 1 to 5. What do we find when we substitute in 5? When you substitute in 5? It's 218. What? No. What happens when I substitute 5 in? When I substitute in 5? Yeah, which is not prime. Okay, so I'm going to get 6 cubed minus 5 cubed, which is 91. This is not prime. Okay? 7 times 13 is 91, so it's not prime. Therefore, statement is false. 15 might also work, but 5 is also correct. 5? Yeah, when you substitute in 5. When n equals 5. 91. 91 is not prime. 91 is 7 times 13. No, you don't need to add any other reasoning because we've shown here, look, we put 91 not prime, 7 times 13. Okay, hence, or therefore statement is false. Okay, part II. I think this is a lovely question, by the way. In the mark scheme, there's like 5 different methods. Okay, so we can have a look at a few. Let's see what comes to me when we do it. So given that the points lie on a circle, prove that AB is the diameter of this circle. So all of these points lie on the circle. Okay, everyone happy with that? This is a fact. Now, I've got something that comes to me straight away. It might not be the easiest. I don't know. We can debate which one's the easiest one. Okay, so all points lie on the circle. So we've got 1, 0. Now, you know, I like to imaginary draw things. So 1, if I had an axis, where would 1, 0 be, roughly? I'm going to say 1, 0 is, okay, so B is going to be down here for me. Okay, this is going to be my 3 minus 10. Okay, or actually, I'm going to put it here. Now, this may not be completely accurate. And then 7 minus 6, this is going to be my C. And then 1, 0, it's going to be here, my A. Okay, so if A and B are a diameter, okay, now let's say they meet with C. Now, this is the first thing that comes to my mind. I know what you're thinking. We could do Pythagoras. We could do Pythagoras, absolutely. I'm thinking circle theorems, 90 degrees. So I need to show that the gradient of AC multiplied by the gradient of BC is minus 1. That means that they're perpendicular and the angle is 90 degrees. Because remember, angles in a semicircle meet at 90 degrees. That's how we could prove it using that circle theorem. Another way we could prove it, if they create a right angle triangle, we could prove that the distance AC squared plus the distance CB squared is AB squared, because then we're proving it's a right angle triangle. Okay, but it has to be using the circle theorem. Now, for this, you have to make sure that whatever you're writing is coherent. Remember, it's like a proof question, okay? You've got to imagine whoever's reading this is dumb, okay? So we're going to go ahead and do the circle theorem way. So if AB is a diameter, then the gradient AC multiplied by the gradient of BC is equal to negative 1. Why is it equal to negative 1? Yeah, and that's because angles in a semicircle create 90 degrees at the circumference. So you can even put in the circle theorem. Circle theorem. Angle in a semicircle is 90 degrees. Okay, so then let's start proving. So what is the gradient of A and C? So we're going to do minus 6 minus 0 over 7 minus 1. So I'm going to get 6 over 6, which is negative 6, over 6, which is negative 1. Then we have the gradient of BC, which is minus 10 minus 6 over 3 minus 7, which is negative 4 over negative 4, which is 1. So then we know that minus 1 times 1 equals negative 1. Okay. Therefore, perpendicular, because this is what it shows, right? Therefore, perpendicular. Therefore, AB is the diameter. Therefore, proved. Now, we don't have to write more than this because we already stated what we were doing here. If you went straight in and was just doing all the gradients, then actually you would then need to write this at the end. I don't know. You not specifically therefore proved, but therefore AB is the diameter, therefore proved. I think it's just good practice to write therefore proved. Okay, question 4. Given that A and B are positive constants, so we need to make sure we remember that. So it's always good to highlight anything that we need to refer back to. Solve the simultaneous equations. Perfect. Okay, so we have to solve these simultaneously. Now, this is quite easy. First thing I'm going to do is I'm going to rearrange A. So A equals 8 plus B. Okay, so then I have log to the base 4 of A. Instead of writing A, I'm going to write 8 plus B plus log to the base 4 of B equals 3. What do I now do if the bases are the same? Yeah, we can multiply them using the log laws. So I get log to the base 4 of B lots of 8 plus B equals 3. Okay, what can I now do? I could expand if I wanted to. So log to the base 4 of 8b plus b squared. Are you happy if I write b squared plus 8b? Equals 3. Okay, now what do I have to do? Yeah, 4 cubes. So we know 4 to the power of 3 equals b squared plus 8b. Okay, so 4 squared plus 8b minus 64 equals 0. Now I need to solve this. Now when I solve this, two numbers that multiply to give me 64 and add to give me 8. Oh God. Right, if my brain's not working and I need to use my calculator, what can I use? Yeah, I can just use a quadratic equation. You can solve this any way you like, okay? So, I'm going to get b equals 4 plus minus 4 plus 4 root 5, or b equals minus 4 root 5. Now, what were we told about a and b? Positive constants. So what do? We reject the negative one. Okay, we're going to keep the positive. Now that I know what b is, how do I find my a? I'm going to sub it into the first equation. So a equals 8 plus b, which is minus 4 plus 4 root 5. Okay, now I'm then going to get positive 4 plus 4 root 5. But also, and this is something we need to keep aware of, what happens if I substitute the second b into, what happens if I substitute in the second b? What do I get? Okay, when we put in the other one as well, the one we rejected, if a equals 8 plus minus 4 minus 4 root 5, I then get a equals 4 minus 4 root 5, don't I? Is that right? Everyone happy with that? Now, what is this as well? This is? Anyone know? It's a negative number, so we will need to reject this. So the only answers we can have is a equals 4 plus 4 root 5 and b equals minus 4 plus 4 root 5. Okay, now that's a nice easy 6 marks. If you put an extra solution in there, you would not get the full marks. You only get 6 marks. You only get 6 marks if the last two solutions, you only have those two solutions. Okay, so make sure you put reject. Well done. Okay, question 5. So, with this question, we need to make sure whenever you see degrees or radians, what's the first thing you should put your calculator into? Yeah, degree or radians. So I've got a trick question. It says degrees. Make sure your calculator's in degrees. That's the first thing you should do. Then it says 3 tan theta plus 43 equals 2 cos of theta plus 43. Okay, so 3 lots of tan theta plus 43 equals 2 lots of cos theta plus 43. Okay, there's nothing I can really do right now because I have tans and coses. Remember, I want one trig identity. What do I definitely know about tan? Yeah, silly cow. Sine over cos. That's how I remember it. So I get 3 lots of sine theta plus 43 over cos theta plus 43. Now, one of the biggest mistakes people make here is that they do 3 sine over 3 cos, and that's incorrect because the 2 3's will cancel to give you 1. Okay, remember it's 3 lots of this equals 2 cos theta plus 43. Now, I can multiply both sides by cos, so I'm going to get 2 cos squared theta plus 43. What do I know that cos squared is? Yeah, 1 minus sine squared. Why? Because sine squared plus cos squared equals 1, and tan equals sine over cos, silly cow. Okay, these are the 2 things you need to memorize. So I know that cos squared is the same as saying 2 lots of 1 minus sine squared theta plus 43. Now remember, well, there would be no need to, you wouldn't want a square root. In general, what, sorry, repeat the question.
So cos, can I say 1 minus sine?
No, cos is not 1 minus sine. That's only cos squared. It's used as Pythagoras. A squared plus b squared equals c squared. Technically, that should say 1 squared, but we know that 1 squared is 1, yeah. And then I have my 3 sine theta plus 43. Now, remember, this is 6 marks. You need to be showing all stages of your working. It literally says that in bold. Don't skip steps. Okay, that's lazy. Okay, so then I'm going to have 3 sine theta plus 43 equals 2 lots minus 2 lots of sine squared theta plus 43. Okay, so I can rearrange this now. So 2 sine squared theta plus 43 plus 3 sine theta plus 43 minus 2 equals 0. What do I have?
You can make sine squared theta plus 43 x.
It's a quadratic, yeah. So I can, if I want to, imagine that sine is x or y. This is the same as 2y squared plus 3y minus 2 equals 0. So you can say let sine sine. Okay, this is by letting. Now you don't have to do this. Okay, you can do it just from, I'll show you 1 second. Right, so let's solve this. So 2 plus 3 minus 2. Okay, so I get y equals a half, y equals minus 2. However, solutions relying on the calculator are not going to get you full marks. So you know what you need to make sure you do? I would write that down here. And then you know, oh, it won't let me pretend I didn't write that. And then just write your brackets. So you know that this is 2y minus 1. And you know that this is y minus 2. If you do not know that, you should not be using, plus 2, thank you. If you do not know that, you should not be using a calculator to solve your quadratics. You need to use a quadratic formula, okay? Now, similarly, if you didn't want to let y equal, you could just do this. 2 sine of theta plus 43 minus 1 bracket sine theta plus 43 plus 2. Okay, you can do that. So you see I factorized it there. Either way is fine. Right, so what do we know now? I know then that sine of theta plus 43 equals a half, and sine of theta plus 43 equals negative 2. So what do I do now?
Minus 4 sine. Wait, but the king, that's where I stopped, because the king error.
Okay, well, there will be an error. For both, it shouldn't. Inverse sine of a half is 30 degrees. Have you got your calculator in degrees? Bring me your calculator. Let me see what you're doing. And then when I inverse sine of minus 2, what do I get? I will get an error. Why will I get an error? Because the sine graph goes up to 1 and minus 1.
Wait, you wouldn't minus 43 first?
Oh, no, don't be ridiculous. Why would I minus 43 first? So remember, guys, from here to here, in the calculator, it should say sine minus 1 of a half. That's going to give me 30 degrees. Now, something I need to do. I need to also change my interval. This is theta. What do we have? Theta plus 43. Okay, yeah, so we have sine of theta plus 43 equals 30. So what we know is that theta plus 43 equals 30 degrees. Okay, now I need to use the cast diagram or or I can use symmetry, whatever's easier for you. And I need to make sure that I change my boundaries here. So what do we have? Theta plus 43, okay? So if this is theta plus 43, what have I done to each side? Okay. I have added 43, so this is going to be 223 and minus 182 plus 43 is minus 137 degrees. So now these are my bounds, okay? So if I was to do my CAS diagram, we have sine of, what was it? 30 degrees, yeah? So we have our 30 degrees. Sine always reflects in this line. So here's my 30 degrees. Okay, so we're going to start from 0 and go to 223 as my first one, okay? So 0. It crosses once. Okay, so 30 degrees. This is 90. This is crosses again at 150. This is 180. Where is 223 roughly? We could say it was about here, right? So then I stop. So I know 30 and 150 is part of the answer. And then if I was to go backwards from 0 to minus 137, 0, minus 90, do I cross anything? No. And then this is going to be my minus 137 here. And again, I have crossed anything. So my two solutions are 30 and 150. Now, if you haven't learned CAST in Pure 2, let's just see what this looks like in terms of the graph. So you know sine looks like this. Okay. What we want to know is 30 degrees is a half, which is here. So we can see we have two solutions and two more here. However, this is just the sine graph, right? We haven't actually, this is a shift, isn't it? We want to be looking between 223, which is about here, and negative 137, which is about here. So we can see anyway, there's only two solutions in the interval we're looking at after the shift. Okay. So we get 30 and 50. So we would write, why can... I'm hoping it's going to follow. Okay, so what do we get? Theta plus 43 equals 30 and 150. So theta equals, I'm going to take away 43, aren't we? So 30 minus 43 is negative 13 degrees, and 150 minus 43, which is 107 degrees. So those are the two answers that you should be having. Okay, in a geometric sequence. Now, the first thing we're going to do is go to the formula sheet. So we know that un equals ar to the n minus 1, sn equals a 1 minus r to the power of n over 1 minus r, and then we also have the sum to infinity. We may or may not need it. Okay, so it says the common ratio is r. Brilliant. So r equals r. And it says u2 plus u3 is 6. Okay, we don't know what a is at the minute. And u4 equals 8. Okay, so the first thing we can do is write all this in terms of the formula. Okay, so what is u2? u2 is a r to the 2 minus 1. So actually, u2 is just a to the power of r. Okay, so when you don't know what you have to do, just do what you do know. and then we should start seeing some equation we'll be able to play with it. U3 equals AR to the 3 minus 1, which is AR squared. Okay? So what do we know? We know that AR plus AR squared equals 6. So currently, we've just translated what we know. And you're going to get marks for this. So even if you're not sure, just do what you do. Okay? Then it says U4 equals 8. So U4 equals AR 4 minus 1. So AR cubed equals 8. Okay? So now we have two equations. So you can do this many different ways. Simultaneous, if you want. Okay? So if you wanted to, you could say that this is A bracket R plus R squared equals 6. And then you know that the second one is A equals 8 over R cubed. And we can substitute in A. So 8 over R cubed bracket R plus R squared equals 6. So I'm going to have 8 over AR cubed times R. This R is going to cancel with this one. It's going to be 8 over R squared, isn't it? Yeah? When we expand the bracket. And then 8 over R cubed multiplied by R squared is going to give me 8 over R, and this equals 6. Now, what I want to do is multiply everything by R squared so that we don't have our R's on the denominator. So 8 over R squared times R squared is 8. 8 over R times R squared is 8R equals 6R squared. I'm going to move everything to the right-hand side. 6R squared minus 8R minus 8 equals 0. Okay? So now I can solve this into my calculator. Got polynomials, so we've got 6 minus 8 minus 8. And I get R equals 2 and R equals minus 2 over 3. So we have two values. Now we should always double check the question. Did it tell us R is positive, negative? What did it say? Oh, it didn't. Right, we've gone ahead of ourselves. It says that show that R satisfies this equation. Okay, so actually what we need to do is divide everything by 2. So we get 3R squared minus 4R minus 4 equals 0. Therefore shown. Okay, now I know we solved it, but let's just put a pin in that for the moment. Okay? Right, we might need that in part B. Okay, that's part A done. Right, part B. It says, given that the geometric sequence has a sum to infinity. Now, if a geometric sequence has a sum to infinity, that means my R is in between 1 and negative 1. Okay? So, given that it's that, does R equal 2? No, so we reject that. So actually R equals minus 2 over 3. Now, sometimes in the equations it will say it's positive, negative. If it says it has a sum to infinity, you know it's between 1 and minus 1. And it says find U1. Okay, so what is U1? So U1 equals A times R to the power of 0. And actually, you know what? Sometimes this happens where you get, you start writing. But remember, what is the first term always? It's always A. Always A. So we can substitute this back into, I'm going to put it in A equals 8 over R cubed. So it's minus 2 over 3 cubed. And then I get minus 27. Okay, so my A is minus 27. And then part C says find the sum to infinity. Now, the sum to infinity is the formula. A over 1 minus R. So we're going to have minus 27 over 1 minus bracket minus 2 over 3. Remember, always use brackets, especially because when we put negatives in, sometimes the calculator gets confused. And then we should have minus 81 over 5. Perfect, full marks. Yeah? Okay, question 7. F of x equals ax cubed plus 6x squared minus 4x plus b, where a, b are constants, given that x plus 2 is a factor of f of x. What does that mean x plus 2 is a factor. That means when I substitute in f of minus 2, my remainder equals 0, okay? So it's like BRB means be right back. X plus 2 is a factor of fx means f of minus 2 equals 0. Okay, it's translating what we've been given. It then says that the integral between 5 and 3 is 176. So again, when I integrate it and put in 5 and 3, I'm going to get 176. What we're going to do is work this out, and I'm going to have some simultaneous equations. Okay? So the first clue we were given was x is minus 2. So I'm going to have a lots of minus 2 cubed. Now, a lot of people mess up here because for the second one, they'd put 6 lots of minus 2 squared. If you don't put the brackets in, if you put minus 2 squared into your calculator, you get minus 4. But we all know that minus 2 squared is 4. So this is what your calculator gives you. If you do not put it in brackets, your calculator will give you the wrong answer. You're going to mess up. You're going to have to start again. Please be mindful of that. Okay? Minus 4 lots of minus 2. So when in doubt, get your brackets out. All right? Plus b. Okay. Need a calculator. So you know that you're going to have negative 8a plus 24 plus 8 plus b equals 0. Okay, so we're going to end up with b minus 8a plus 32 equals 0. And you can leave it like this if you like. You don't have to change it for a second. But there's our first clue done. Now our second clue. So we need to integrate this. Okay, so the integral of ax cubed is increase the power by 1 and divide by the new power. Okay, 6x squared, increase the power by 1, divide by the new power. Minus 4x, increase the power by 1, divide by the new power, plus bx. Okay, now let's simplify this a little bit. I'm going to have ax to the power of 4 plus 3x squared minus 2x squared, sorry, that's cubed, plus bx. Now I'm going to substitute in the values of 5, then take it away for when I substitute the values in of 3. So if you think here, I'm going to have a bracket 5 to the power of 4 over 4 plus 3 lots of 5 cubed minus 2 lots of 5 squared plus b lots of 5. I'm going to simplify it, take that away for the same again, but this time I've got my 3 plus 3 lots of 3 cubed minus 2 lots of 3 squared. Oh my god. I mean, it's 7 marks, so you can see why there is a bit of writing. That's fine. Okay, so let's try and sort this out. So I'm going to just put everything into my calculator. 5 to the power of 4 divided by 4. Okay, so I get 625 over 4a. I'm going to put these two in my calculator at once because these are just my constants, my number. So 3 lots of 5 cubed minus 2 lots of 5 squared. I get 325 plus 5b. Awesome. Now I'm going to minus 3 to the power of 4 is 81 over 4a. Again, I'm going to just do this all in one go. 3 times 3 cubed minus 18 plus 63 minus 3b. Okay, so what I'm going to have, I'm going to have 625 over 4 minus 81 over 4. Okay, so I get 136a. 325 minus 63 is 262, and then plus 5b minus 3b is 2b. Now remember, this equaled something, didn't it? What did it equal? 176. Okay, so I'm going to have 136a plus 2b equals 176 minus my answer. I get minus 86. Okay, I had that other one from earlier, didn't I? Here it is. Okay, what I'm actually going to do is rearrange the first one. I'm going to have b equals 8a minus 32. I'm going to substitute that in here. So we're going to have 136a plus 2 lots of, I forgot what I said, 8a minus 32 equals negative 86. Okay, so we should be able to expand and simplify this pretty simply. So 136 plus 16 to get my a's, I get 152a equals minus 86 plus 64. Again, minus 22. God, I think I've gone wrong somewhere.
262.
Yeah.
I got 164.
You got 164.
Yes. This is one minus.
I got 325 minus 63.
Yeah, I got 200 minus.
Is this one wrong? I've definitely gone wrong somewhere.
I think the 63 is right, but the 200 is wrong.
The 63 is right, but the 200 is wrong.
No, the 63 is also wrong.
Okay, let's just put this in my calculator again. Oh, I know where I've gone wrong. This is a very silly mistake. Guys, what's 6 divided by 3? It's a 2. Okay, it's okay to make mistakes. At least we know when we got those numbers that we were wrong. Okay, so 2 times 5 to the power of 3 minus 2 times 5 squared. Okay, so got 200 here. And then for the other one? You forgot, that's fine. 2 times 3 cubed
36.
minus 2 times 3 squared. 36. So then what do you get?
So that's divided to 136.
So 164.
Yeah.
Okay, 176 minus 164 is 12. So this equals negative 12. Yeah? Oh, it's positive 12. Yeah. Okay, so now I'm going to have positive 12 plus 64. I get 76 here. Does that seem a bit better? Because 2 times 32 is 64. 64 plus 12. 76 divided by 152 is a half. So A equals... Yeah, I'm doing simultaneous now. So I substituted in, sorry, before my mistake. I rearranged the first equation and substituted that in here. Okay, so now I get A as a half. That sounds a bit better than whatever I had. And then B equals 8 lots of A minus 32. So B equals negative 28. Okay, now I can double check those. Looks about right though. But we can just use either one. Okay, so there we go. Nice and simple. And remember, it's okay to make mistakes. You just need to be able to spot them quickly. All right. Okay, so question 8, part A, differentiation question. 256 times 4? 1024 x cubed. Remember, bring the power down, take away 1 from the power. Minus 304. Now, remember, 27 over x squared is 27x to minus 2. So we're going to have minus 54x. Bring the power down to the negative 3. So have we found dy by dx? Yeah, you get 1 mark for each, essentially. Nice and easy. Okay, part B. Hence, find the coordinates of the stationary points of the curve. Now, what do we know about stationary points? Gradient equals 0. This is the first thing you should be writing down. Okay, gradient equals 0. So, what I'm going to do is I'm going to rewrite this. I'm going to do 1024. Well, if you wait, you'll see. 304 minus 54 x cubed. 54 over x cubed. This equals 0. Okay. Now I know what's happening. I can spot it already. We have a hidden quadratic. Okay, let's multiply everything by x cubed first. So if I multiply everything by x cubed, what do I get? 6 minus 3 minus 54 equals 0. Okay, here we have a hidden quadratic. Why is this a hidden quadratic? Because x to the power of 6 is the same as saying x cubed squared. Now, if it's easier for you, you can write this in terms of y. So you just say, let y equal x cubed. So we're going to have 1,024y squared minus 304y minus 54 equals 0. Okay, I'm literally going to just put this into my calculator to find out solving the quadratic. Okay, and what I then get, my answer is y equals minus 1 over 8 and y equals 27 over 64. Okay, these are my two answers for y. But what does y equal? X cubed. So x cubed equals minus 1 over 8 and x cubed equals minus 27 over 64. So I need to cube root both of these. So x equals the cubed root of negative 1 over 8 is negative a half. You can literally put it into your calculator like this. Now, remember, with cube root, we can have negatives inside. And then the cubed root of minus 27 over 4 is minus 3 over 4. Okay, so now we have our two x values. Now, please read the question. Did it just want the x coordinates? Did it want the x and y coordinates? What did it want? Yeah, it says find the coordinates. What are coordinates? X and y. So I know now. Yeah, we need to substitute the x value back into the original equation, the y equals this one here. Okay? So I'm literally going to type into my calculator. Y equals 256 bracket something to the power of 4 minus 304 bracket x minus 35 plus 27 over bracket something squared. Now, please use your brackets, especially because our x values are negative. Okay? So, when we get this, we substitute in. The first one I'm going to put in is minus a half. I get 241. And then when I put in minus, is it minus 3/4? No, that's a positive. Okay, when I put in positive 3/4, sorry, I'm just making minuses. I get minus 134. Okay, so that's a lovely 8 marks, actually. Great work. So, a scientist is using the carbon-14, blah, 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 etc. So you should have really had a look at, read this question already. Now, it's a sketch a graph of n. Okay, so what do we know? That n equals k lambda to the power of t. Okay, so it doesn't really matter what type of graph this is. This is like any, essentially, exponential graph, isn't it? Like y equals 2 to the x, or y equals e to the x. Yeah? And what do we know about exponential graphs? How do they look? They normally look like this, don't they? Yeah? And where do they cross? At 1. Okay, why? So this isn't the answer, though, because what do we know about our number here? Now, this is 2 to the x, e to the x, etc. What happens if I have a half to the x? Okay, because it says that our lambda is between 0 and 1. So that means that actually our graph, yeah, is going to look like this. And this is our 0, 1. Because if you think about it, when we put it to the power of 4, it's going to get smaller, isn't it? When we put this to the power of -2, well, what does the -2? The negative flips this, yeah, and then we square it so it gets bigger. Now, because it wants you to sketch the graph, make sure that we write that this is over time. Okay, just like in this one, this is our x, and this is our y, which in our case is n. Okay, so this is how it should look. You need to make sure you have these labelled. Right. Part B, what do we have to do? We do have to do math. What type of math do we have to do? It says, given that it takes 5,700 years for the amount of carbon to reduce by its initial value, okay? So we're going to create an equation. So I know that the initial value is K. And if it says reduce to half of that, this is a half K. So my reduction of a half K, what does this equal? This equals K lambda to the power of 5,700. What do I have here? An equation which I can solve. So what am I going to do to both sides? Yeah, divide by K. If I divide by K by both sides, I get half equals lambda to the power of 5,700, isn't it? Yeah? Then we can do logs, can't we? Yeah? Or, instead of doing logs, because we don't need the x, we can do a half to the root of 5,700, couldn't we? Yeah? So we don't need logs. We need logs when it does it to the power of x. But with this is like saying if a half equals x squared, how do we find x? We square root it. Okay, so when we get this, we're going to get lambda equals, and in your calculator, you should get 0.99. What'd you get? 874026. Perfect, which is, to 6 decimal places, 0.999878. Therefore shown. Okay, so we've shown that value in part B. Right, nice and simple. Now it says, given that part, no, it says A, right? Yeah? So, A. Given that item A is known to have had 15 grams of carbon-14 present initially, what does that mean? Lambda equals, or K equals, or N equals? It's K, because it said K was our initial value, right? So K equals 15. Okay, so from this, we're going to write down what we know. Then it says it's thought to be 3,250 years old. So what's that? What else am I missing? T, which is 3250. Do I know what lambda is? Yeah, 0 point exactly. And because it's to 6 decimal places, I'm going to use that. So literally, I'm going to put this into the equation. So I'm going to get n equals 15 times 0.999878 to the power of 3250. Literally substituting that into my calculator. Okay? And when I do that, 15 times 0.123878 to the power of 3250, I get 10.0898, etc. But what does it want? Three significant figures, okay, which is 10.1. Nice and simple. Then it says item B is known to have initially had 25 grams. What is that? K. So K is 25. But only 18 grams now remain. So what does that mean? N equals 18. We already know what lambda is. What do we need to work out? T to the nearest 100 years. Okay? So, what's the formula? 18 equals 25 times 0.999878 to the power of t. I'm going to divide both sides by 25. 0.999878 to the power of t. Now what am I going to use? Logs. Exactly what I wanted to do. So log to the base 0.999878 of 18 over 25 equals t. Okay? When I put this into my calculator, I'm going to get 2,692.49. And it asked me to round it to the nearest 100 years. So t is 2,700 years. That is a lovely question for 9 marks. There is no reason, okay, you might have got the graph wrong, but you might get 1 mark there. But the other marks, there's no reason why you shouldn't be able to get 4 marks on that. Okay, question 10. The circle has center 3, 5, and radius r. The line has the equation y equals 2x plus k, where k is constant. Show that the line L and C intersect when. Okay, so first things first, let's write down the equation of the circle. So what do we know the equation of the circle is? X minus 3 squared plus y minus 5 squared. What does this equal? R squared. Okay, so this is our equation of the circle. Now, if they intersect, okay, simultaneous equations, yeah, we can use substitution. We can substitute 2x plus k everywhere there is a y, and you can clearly see that they've expanded. So let's have a go. So x minus 3 squared is x squared minus 6x plus 9 plus 2x plus k minus 5 squared equals r squared. Okay? Now, remember this k minus 5 is a number. Okay? So technically, we're going to have x squared plus 6x plus 9. When we expand this, we can just expand it as normal. They're just trying to trick you a little bit. Okay, so we go 2x times 2x, 4x squared. 2x times k minus 5 is plus 2x bracket k minus 5. Then we've got the 2x times this again. Okay, so we're going to actually end up with 4x. Because 2x, lots of that, plus 2x, so that's 4x. Then lastly, we're going to have plus k minus 5 all squared. And then minus r squared equals 0. Now, you can see they've clearly expanded everything, so let's keep going. So then we're going to have x squared plus 6x plus 9 plus 4x squared plus 4xk minus 20x plus k squared minus 10k plus 25 minus r squared equals 0. Okay, this should be just easy, just might be a bit long-winded, so let's sort it out. Okay, so we've got 5x squared. Okay, then we've got 6x, 4x, 20x. These are my x's. So what is 6x minus 20x minus 14x? So remember, they took out the x here, didn't they? Oh, right. Okay, so this is really good. I've made a silly mistake. Remember, it's minus 26. For some reason, I've written minus, I've put plus here. Just make sure you check what's going on. Okay, so this is going to be minus 26 plus 4k, because we're essentially factorizing out the x. Then we have the k squared, so plus k squared minus 10k. Then we've got 9 plus 25 is plus 34 minus r squared equals 0. Perfect. And that's exactly what they've got. Now, it then says, given that L is tangent to C. So if L is tangent to C, what does that mean? If it's tangent, so it means two things. One, the gradient of L is the negative reciprocal of the gradient of the center to be, and it means that it intersects at one point. So the discriminant would equal 0. Okay, so it means those two vital bits of information. So if L is tangent to C, remember this means that the discriminant equals 0, or the gradient of L times the gradient of the radius equals minus 1. Okay, nice two bits of information. So show that 5r squared equals k plus p squared. Okay, so how are we going to show that? I'm going to go with one of the formulas I've got. Discriminant equals 0. Let's try that. Okay, so what do we know about the discriminant? We have A. What's my A? Okay, what's my B? And then what's my C? Okay, so what do I know? B squared minus 26 plus 4k squared minus 4 lots of A lots of C equals 0. Okay, let's get squaring then. So the reason why I chose this as well over the gradients is because I didn't have a point B yet. So here we go. What do we get? 16 k squared minus 50. Oh God, no. Wait there. 4 times negative 26 times 2 minus 208k. And then what's 26 squared? Plus 676. Okay, minus 20k squared minus 200k plus 200k minus 680 minus plus 20r squared equals 0. Okay, so I get minus 4k squared minus 8k minus 4 plus 20r squared equals 0. Okay, I clearly divide everything by 4, right? So minus k squared minus 2k minus 1 plus 5r squared equals 0. And then, oh, perfect. If I move everything to the other side, because it has 5r squared, this makes everything positive. K squared plus 2k plus 1. And then we can factorize this. This is k plus 1 squared. 3 marks. That took a while, didn't it? So p equals 1. Easy. Okay. Next part of the question. The line cuts the y-axis at the point A. Okay. So the line, remember, is 2x plus k. So technically, A is 0k. Yeah? Because the line has this equation, and my k is my y-intercept. Touches the circle at point B, great. Given that AB, so AB is 2 lots of the radius. Find the value of k. Okay. So, we know it's a right angle. We know that this is radius. This is 3, 5. We're not sure what B is yet, are we? And we know that this is 0, k. And this is also 2r, right? Okay. So using Pythagoras, what do we know? So what do we know? So we can literally just use Pythagoras. 3 minus 0 squared plus 5 minus k squared. That equals this line squared, doesn't it? Which is, remember, this is our A. Is that X? Yep, B. Okay. This equals AX squared. So what do we have? 9 plus, where's 5 minus k? Oh, I'll just leave it like this for a second. Plus, so 9 plus 5 minus k squared. Are we happy with that? Yeah? What does this equal? This equals, so we've worked out the length of this. Remember, this equals 2r squared plus r squared, doesn't it? So this is 2r squared plus r squared. So you get 9 plus k squared minus 10k plus 25 equals 4r squared plus r squared. What do we get? 5r squared? What is 5r squared? Yeah, they told us earlier, didn't they? That it equals k plus 1 squared. So they've been a bit sneaky, haven't they? So now I get k squared minus 10k plus 25 plus 9 equals k squared plus 2k plus 1. Because, remember, we know what 5r squared is. So what do we end up with? They're going to cancel, right? I'm going to move the 10 to the other side. Are you happy if I put 12k here? And then 25 plus 9 is what? 34 minus 1? 33. Is that right? So then K equals 33 over 12. So that'll simplify, it should do. 11 over 4. There you go, 6 marks. Okay? So with this one, it required you to use knowledge of 2 bits of information. So you had to do this, or the green here, Pythagoras here, and then obviously the distance between 2 points, and equate them to each other because you know the lengths are the same. Great work.